Now we will do a problem related to PLA. That is, question will be like this. Okay, a CLC, that is combination logic circuit, is defined by the functions f1 is equal to sigma m357 3 comma 5 comma 7, or it can be separated by space. Okay, and f2 is equal to sigma m457. Implement the circuit with PLA having 3 inputs, 3 product terms and 2 outputs. Okay, from the theory that we have discussed in the case of PLA, it's clear that we will have a set of what we call variables and their negation parts, and there will be AND gates and OR gates, and they will be programmable. That's the basic concept regarding PLA. Okay, so when we have such a question, what we do next is the first thing we need to do is, based on this particular what we call the given circuit or the given function f1 is equal to sigma m357 and sigma m457, based on that two functions we need to create a table. Okay, as it is 357, it's not 357, it's 357. Okay, and this is 457. So the first thing we need to do is we will go for a table. Okay, so what will be the set of variables? Okay, we will give A, B, C, and we have F1 and F2. The value of F1 and F2 is given. Okay, so the functions where we have positive terms, or we'll give you the description. Okay, or the how we can construct this. Okay, the biggest value is 7, so we will go for 3 variables, that is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, that is 0 to 7. Just write, if you have any confusion, go for 0, 1, 2, 3, 4, 5, 6, 7. Okay, so in F1, sigma m357 means F1, in the case of 3 we put a 1, 5 we put a 1, that we have learned in the case of min terms, and 7 we put a 1, rest of the values will be 0. Okay, and F2 we have 4, 5, 7, so 4 we have 5 and 7, so rest of the values will be 0. Okay, what are the procedures for constructing this? Okay, we have this table, the truth table. Okay, and after that we will have we need to find the solution for these values. Okay, that is using Carnot map. Then we have a PLA programming table, and after that we go for the final figure. So it's a step-by-step procedure, so take time and please follow how we got this particular table, and rest of the steps will follow. Okay, please go. So what's our next step? Carnot map. Okay, finding a value for F1 and F2. So how can we construct Carnot map? We have the values and we plotted 1, 1, 1 here in the case of F2 also. So based on that, okay, we have we need to find the value for F1. Okay, so initially, so here we plot A and here we have BC, that is 0, 0, 0, 1, 1, 1, 1, 0 and 0, 1. Okay, so I will give the values as well. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so in the case of F1, for 3 we have a 1, and for 5 we have a 1, and for 7 we have 1. Okay, and what about the plotting? This one. Okay, this is one thing, one pair, this is the next pair. Okay, so as I said earlier, plotting this upwards means we have B term gets cancelled, plotting this upwards, B terms will cancel, and we have C. So plotting this leftwards, we have AC plus, next one is plotting this leftwards, the A terms get cancelled. Plotting this upwards, we have BC. Okay. Let me check the answer. AC plus BC. Yes, this is correct. And the next step, finding a value for A and BC 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So, giving the values 0, 1, 2, 3, 4, 5, 6, 7. Okay. And how can we plot the terms? For F2, right? So, we write here F2. F2 is equal to, this is 4, 1 value, then 5, 1, and 7. We have another one. Okay. So what we do here is, we go for the pairs. There is no quads, so we have pairs only. So we have two pairs. Plotting this upwards means, the C term get cancelled. So we have, plotting this leftwards, we have A, B bar plus, plotting this upwards means, again we have an A value, and plotting this upwards means B term get cancelled and C is the answer. So A, B bar plus AC is the answer. Okay, it's not over. Please go through. We solved the Carnot map. We got a value, but I have repeated this particular truth table. There is a reason for it. So when you write in paper, it's already there. No need to repeat it. But the next step is to create the program or the PLA program table. Okay. In PLA program table, what we do initially is we need to find the product terms in that particular expressions. Okay, that is in the above expression we have found AC repeating. It's AC, right? Yeah. It's the answer was F1 is equal to AC plus BC and F2 is equal to A bar B plus AC. So AC was the set that was repeating. So I have written that case only once. Okay. And BC was there, A, B bar was there. I repeat, we had F1 is equal to, I have written the answer over there. F1 is equal to AC plus BC that we have already derived, and F2 is equal to A, B bar plus AC. Okay, so based on that, we need to find the product terms in that particular set. Okay, so we have AC, BC and A bar B. Sorry, A, B bar. Okay, so like what we have done in the case of Quinn-McCluskey method, what we need to do next is, here we initially had the set of values A, B and C, variables A, B, C. So we have AC here, so 1 and C is 1. Okay, here we put a dash. Clear? Then BC, we have dash 1, 1. Okay, and A, B bar means A, 0, dash. Clear? Then look at the table for that. Okay, ABC 1 dash 1 1 dash 1 1 0 1. We have 1 0 1 and 1 1 1. Right? We have 1 0 1. Okay, value of A is 1, value of C is 1. And what is the value of B? 0 and 1. Okay, that is, we can have a 0 value, can have a 1 value. So, what we do is, what is the answer for F1 and F2? We have, for both these cases, the value is 1, 1. So, we put the value 1, 1. Okay, I repeat, put the value of A and C as 1, because we already have that case. Okay, that is, they are positive, A and B. For negative cases, when there is a bar, we put a 0 value. And 1 dash 1 means, look at the table, and where is that pattern followed? 1 dash 1. We have 1 0 1 and 1 1 1. Okay, that is A and C values strictly kept stable, and B value has changed. Okay, in that case, I find the value of F1 and F2. We have 1 1, so we put the values 1 1. Okay, so I think you got the idea for that. So our next step will be dash 1 1. 1 1. Here we have 1 1, right? Here also we have 1 1. Let's check. 1 1 in the case of B and C, and here also 1 1 in the case of B and C. Okay, what are the two terms? 0 1 1 and 1 1 1. These two terms are kept stable, constant 1 1. Here 0 and 1. What is the corresponding value? 1 0 and we have 1 1. Right? 1 0 and 1 1. In that particular case, F1 holds the value 1. The value of F2 is 0 and 1, so we put a dash. Clear? Our next step is 1 0 dash, right? A B bar 1 0 dash 1. We have 1 0 0 and 1 0 1, right? 1 0 0 and 1 0 1. What is the corresponding value? 0 1 and 1 1. So it means that F2 holds the value 1, that's constant term, and F1 will be dash. Okay, and I have put a value TT. It's not so important, but at times we find that in problems, in textbooks we have written the value T, variable T. Okay, T denotes the true condition if the output inverter is to be bypassed. Okay, if you have confusion, bypass means here in the final figure we can understand how they got bypassed. Okay, how they they have a connection. So if it's difficult for you to memorize, go for just write T denotes the true condition. Yes, that is enough. Okay, we have written TT for here. Okay, so understand how we constructed this PLA, that is PLA program table. Please go. We have already constructed the truth table. Next is finding an expression for F1 and F2, and after that we constructed the PLA program table. Okay, and from that we found what are the true conditions and all. Okay, now we go for the figure. See, we have already drawn A, and this is the case. Okay, one positive part and one negation part. Okay, you can go for such figure, or if you want you can draw a figure like this as well. Okay, it's up to you. This is, if it's A, this is A, then this is A bar. Okay, so we can draw like this as well. Okay, this is the figure. Okay, I repeat, one positive and one negative. Okay, so this is simply the initial case. So we are about to draw the figure. Okay, A bar, A bar, B bar, C and C bar. Okay, so we need to find expression for first of all F1 and F2, right? Okay, we need to find such expressions. So what is AC? Yeah. Okay, where is A? We have A, we have a C. Okay, we form an AND gate. Okay, if we form an AND gate, this is AC. Then we have a BC. This is B, this is C, this is BC. Let me check. Yes. Now, what was the terms? The product terms that we have already learned. Okay, we have AC, we have BC, we have A B bar, A and B bar. Okay, clear? Let me check. Yes. So what we do next is we extend these lines Okay, so we found AC, we found BC, we found AB bar. Okay, now what are the OR terms that we need to construct? F1 is AC plus AC plus, one second, yeah, AC plus DC. This is F1. Okay, next question, sorry, we have F1 and we need to construct F2, right? AB bar. So this is one AC. We need not draw this one. We can even line directly like this. If you want, we can put that also, no issues. Okay. If we put an into here also, no issues. If we don't put, because AC is given directly to, so we put another OR gate. We have F2. Let me check. Okay. AC, BC, AB bar, F1, F2. Okay. This is a figure. This is the final figure. I will give you a question. Please try to solve it. Question pattern is same. Find construct CLC like that. So the question is F1 is equal to or F1 of ABC is equal to sigma m 0 1 3 4. F2 is equal to ABC sigma m 1 2 3 4 5. 1 2 3 4 5. One is 1 2 1 0 1 3 4 and 1 2 3 4 5. I think it's clear to you right now. If you want, we can make it. Okay, it's enough. Try to find the value for this also and construct the figure. If you have any doubt, feel free to ask.